Okay, I think we can slowly start the webinar. As I can see, everybody joined with their accounts. Okay, so again, hello everyone. My name is Philip, and I am representative of the technical support team here at akYtec. And today I will be presenting our line of industrial process indicators, which are compact, robust devices that make monitoring clear, reliable, and simple. Before we dive in, just a quick note: if you have any questions, please feel free to write them down in the chat. My colleagues from technical support team are also in the meeting, and they will be answering in real time. At the end, I'll also leave some space for any additional questions. Okay, we can start. I will be sharing the presentation that we prepared for you today. Okay, I hope everyone can see this presentation. So let's start. First of all, before we dive into the product line, let me briefly introduce our company. akYtec is a German industrial automation equipment manufacturer founded in 2010 with headquarters in Hanover. We serve over 3,000 customers from Europe to Australia, supported by a wide network of distribution partners. Our own product facility is located in Serbia, where we handle plastic injection molding, SMD production, and final assembly and quality control. In the pictures here, on the above picture, you can see the outsides of the factory. The factory is located at the southern part of Serbia in a city named Niš. And on the bottom picture, you can see the insides of the factory. This is one production line in our factory. Our product categories include PLC plus HMI devices, mini PLCs, input and output modules, softwares, of which Tool Pro and ALP, industrial process displays, for which we're going to talk about today, and sensors and transmitters. At akYtec, we cover the full cycle. So we do research and development to create compact and practical solutions. We do the testing to ensure the reliability, production, of course, for consistent quality, and service and support to help you with selection, setup, and integration. This way, every device is durable, easy to install, and ready to perform in real applications. So, for today's agenda, here is what we will cover. First, we'll give you an overview of our indicator product line. Then we'll go step by step from indicator to indicator. The first one being ITP 11, which is our loop-powered indicator. The ITP 17, our new three-color universal indicator. The ITP 15M, which is our updated LED bar graph indicator. And finally, the SMI2-M, our Modbus-based display. Throughout the session, I'll also share some industry examples, so you'll see not only the technical details, but also how these indicators are applied in, for example, food production, brewing, fisheries, recycling, shipping, and much more. By the end, you'll have a clear understanding of how each device works, what makes it unique, and how it can be integrated in your system and bring you value to your own applications. So on this slide, you'll see the full akYtec indicator family. On the left, we have the core modules, ITP 11, ITP 14, and ITP 16. In the middle, we have ITP 15. And on the right, we see our newest and updated products, ITP 15M, ITP 17, and Modbus indicator SMI2-M. All of these products are designed with the same philosophy: wide compatibility, So they support various types of input signals with built-in on and off control, high accuracy. Measurements are precise with up to 0.2% accuracy, rugged build, with IP65 rated front panel. They are resistant to dust, humidity, and splashes of water, perfect for any harsh environment. But what is the main feature of the ITPs and SMI2-M indicators? That is its size. So it compact size, just 65 or 72 millimeters long, depending on the type, 48 millimeters wide, and 26 millimeters high. They can be integrated into standard boreholes and each fit into 22.5 millimeter borehole. So the same size used for standard signal lamps. This means you can integrate them into existing control panel with no redesign. Simple configuration, whether through buttons or USB, depending also on the device. Setup is really straightforward. So whether you are upgrading an old system or designing a new one, these indicators give you a way to add clear, color-coded visualization without extra complexity. We'll first go over the ITP11. This is the most compact and energy-efficient device in our lineup. What makes the ITP11 unique is that it is loop-powered, as I mentioned earlier. This means it draws power directly from the 4 to 20 milliampere current loop, eliminating the need for any additional power supply. This simplifies wiring, reduces cabin clutter, and increases overall safety. The ITP11 is available in two colors, color green or color red, so you can choose between these two colors for your specific needs. So for example, if you want to monitor the value that is somewhat normal value, you can choose the green indicator, or if it's some extreme value or some critical spot, it can be a red indicator. Also, beside the ITP11, the standard size, we have the wide version, the ITP11W, which will allow you versatile mounting on the wall, as seen in the picture, or in a rail, or even on a tube. This flexibility is particularly useful when you need the local displays outside the control panels. Some of the industry examples of the ITP11 is milk industry, or precisely food industry, milk pasteurization. In this case, the ITP11 provides constant visual monitoring of each temperature and level parameters, helping operators identify issues early and preventing production defects and downtime. Some more examples are brewing industry. Here, it enables intuitive and reliable monitoring of fermentation conditions, improving consistency and ensuring product quality. And we have fisheries and aquaculture. So in these cases, the indicator needs to be resistant to water. So the IP65 rating on the ITP11s is perfect for these conditions. Now, for the first demonstration of today's webinar, I will be unboxing and mounting the ITP11 to showcase you how easy it is to mount it into a standard hole. I'll change the camera now. I hope you can see my other camera. So this is the box in which the ITP11 comes. As you can see here, it's indicated that this is G, so it's a green version of the ITP11. In the box, as you open it, we see the ITP11, our indicator, and here we have a plastic ring for mounting and protective rubber for IP65 rating. I'll move the box out of the way. And here I prepared some standard holes for the signal lamps, buttons, or all kinds of that stuff. So here I have a button, red button, 2 lamps, some resistance, and one empty hole where we will put our ITP 11. So the first thing we'll do, remove the front cover from this little plastic bag. I will remove the rubber and the plastic ring. So to ensure the IP65 rating, I'll put the rubber over the indicator. Like this. And then put the indicator in the hole. On the back, I put the plastic ring, screw it, and that's it. So it's easy as that. As all lamps, buttons, the mounting is very straightforward and simple. Okay, I will switch the camera again and share the presentation. Okay, let's continue. Next on the plate, it's the ITP-17. The ITP-17 is our newest model, and this is a universal 3-color indicator designed for maximum flexibility. The key features of the ITP-17 are that the ITP-17 is 3-colored display. So we have red, green, and yellow color all in one device. This makes it possible to indicate not just good or bad, but also intermediate conditions. We have threshold zones, so you can define up to 4 zones, and each range is displayed with a different color of your choosing. We have the removable terminals of the ITP-17. Unlike previous models, the ITP-17 is a little bit longer, so it has removable terminals, making wiring easy and more convenient. Also, USB configuration with Tool Pro software. This allows you to set up the device quickly with all parameters clearly visible on the screen. It's also equipped with a digital NPN output for on and off control. So, for example, you could trigger an alarm when a certain temperature is reached, or activate a fan when a threshold is exceeded. The ITP-17 replaces 2 previous models, ITP-14 and ITP-16, and combines best of both worlds of those 2. So the ITP-14 was designed to measure signals, which are current and voltage, and ITP-16 was designed to measure RTD and thermocouple signals. The ITP-17 combines these 2, so it can measure all of those signals in one device. Also, it has one additional color of yellow. So 3 colors in one device. As we mentioned, removable terminals because it is slightly longer than its previous models. Here is one practical example of how you can set up thresholds in the ITP-17. So in the Tool Pro software, we can set that measured value, that is, for example, or in this example, below 40, will be displayed in yellow color. So if we have a temperature that is 35 degrees, it will be displayed in yellow color on the screen. If it is between 40 and 80, it will be displayed in green color. Above 80 but below 110, it will be yellow color, and above 110, it will be red color, indicating emergency overheating. In this way, operators have an instant visual feedback, and the system itself reacts automatically to the critical events with the output on and off. Let's go over some industry examples of the ITP-17. In this example of recycling and waste processing, it is used in furnaces, dryers, and extruders. And the ITP-17 helps operators track processes stages at glance. So color-coded digits give immediate feedback: green for normal, yellow for warning, and red for critical. This maximizes operators' error and speeds up response time. The ITP-17 ensures accurate monitoring, preventing underfeeding or overfeeding, which can lead to inefficiency or safety risks. For the second demonstration, I will be unboxing the ITP-17. You already saw how you can mount these devices. It is the same thing for ITP-17 as ITP-11 and all other of our devices, so I won't be mounting it again. So in the box, ITP-17, a little bit longer as we mentioned. We have removable terminals, so I can just plug them out and put them in. We have 3 buttons for programming, for button programming, button M up and down. And we have a USB port, so we can connect it directly to the computer and program it into Pro software. This method is much easier and has, yeah, it's much easier, but if you don't have a computer at hand, you can do it with the buttons. The programming by buttons is explained in user manuals, which also come with every device, as you can see, or you could find these manuals on our site, akYtec's.de. I'll put the ITP-17 aside. Let's switch the camera and share the presentation again. Okay, let's continue. Next on the line is the ITP-15M. The ITP-15M, unlike 7-segment displays on the ITP-11 and 17, uses a 10-segment LED bar graph, as you can see in these pictures. This makes it perfect for visualizing trends or real-time changes. Just like ITP-17, it offers 3 colors, so 3 colors in the same device, configurable thresholds, supports current, voltage, RTTs, and thermocouples, and an NPN output for on and off control. Configuration of the ITP-15 is done either by buttons or via Tool Pro, as we mentioned, same thing in the ITP-17. Here we can see what is updated on the previous version. So we have additional color. It is a little bit longer, so we have removable terminals also, and it can measure RTD sensors and thermocouples. Here is the same example, or it's not the same example, but the same idea. We can set the thresholds in which we will change the colors of the representing value. The different thing is that we do not see the specific value that we measure, but rather a percentage of predefined range. So, for example, if I have a set range of 0 to 10 volts, at 5 volts, 5 segments will lit up, and at 10 volts, all 10 segments will lit up. The thresholds, we already mentioned the example, so it's the same thing as the ITP-17. The only difference, we have the bar graphs rather than specific value. Let's see some industry examples and cases in which this is more beneficial than the specific value. So on ships, on board, operators must make quick decisions. The ITP-15M provides instant visibility even in low light or vibrating environment. This reduces the chance of misinterpretation, which can be critical at seas. We can measure condensate level control. In separator systems, the ITP-15M shows the liquid level as a simple bar graph. Operators immediately see it as a level if it's rising or is dangerously high. Its compact size helps optimize space in crowded control cabin. So, at a glance, you can see the value by the percentage or the number of the graphs displayed. For the third presentation, I will connect the ITP-15M to one PT1000 sensor and showcase you how this is shown. So, let's change the camera. Okay, so the same box, the ITP-15M. We have the buttons, we have USB ports, and here I have one PT1000 sensors. I already removed the terminals, so I can easily put it on. So we have the terminals, we put them here, and we have a power supply here, 24 volts on the other terminal. Okay, missed the side. Okay, there it is. So we can see for now 5 red bars lit up. I will connect the ITP-15 to the Tool Pro software and see what is happening. So let's switch the camera and share the Tool Pro screen. The Tool Pro software is free software that you can find on our website also and used for programming and configuration. On the top left, I click Add Devices. Interfaces, I select COM port 10 for me. For you, it may be some other port. Here I select Modbus RTU and click Find. We found one ITP-15M, and on the bottom right, we click Add Device. It's not shown on the screen, I think, but the button is there. So the ITP-15M that we just added is here. We can expand these sections. And for the input signal, we can see that PT1000 is selected. We have all kinds of sensors here that you can change, RTDs, thermocouples, as we mentioned. We have current signals, voltage signals, etc. And I can see here that the lower limit of bar graph is set to 0, but the upper limit of bar graph is set to 50. So we have a measured value of 22.5, I think. I'll click the read button to read the value that is reading. Yeah, it's 22.5 degrees Celsius currently. And for the range of 0 to 50, or the lower and upper limit, 25 is, we would say, 50%. So the 5 bars are shown. If I change this to 100 and write the parameters with the button, okay, I just noticed that you do not see the ITP. Give me a second. I'll repeat this. So it was 50. I write the parameters, so it's 5 bars for somewhat of a 50%. If I write here 100, the three indicators lit up. So 0 to 10 would be 1, 10 to 20 will be 2, and 20 to 30 will be 3. We are 22.5, so it showcases 3 bars. For the color settings, for the threshold, I set here that from 1 to 20, we have the, or for threshold above 20, I will have red color. So because we are measuring value of 22, the color will be red. If I change this to green, for example, and right, the indicator showcases the green color. Okay, I think that's enough for this demonstration. There are many more things that you can try here, but I leave that to you. Okay, let's switch the camera again. And just give me a second to disconnect the device. Because we will need this space for our next device, which is the SMI2-M Modbus indicator. So the final device that we'll showcase today, the SMI2-M Modbus-based display, unlike previous indicators, which are connected directly to sensors, the SMI2-M communicates over RS485 using Modbus RTU or ASCII protocol. It can operate in 3 modes. So master mode, it requests values from Modbus slave devices and displays them. It can be a slave, so it receives values from a Modbus master and displays them. And it can be configured in a SPI mode, which is somewhat of a listening mode. So the SMI2-M listens to the communication on the Modbus line and shows the value without interfering. The key features of the SMI2-M are that it supports multiple data formats. So integers, double integers, words, double words, etc. It has a flexible configuration of byte and register orders, because the byte and register orders in a real type of data is not, has no standard. We can easily change this in the SMI2-M device. We have automatic color change and blinking in alarm state. So when we reach an alarm state, the blinking can happen. So the value will start blinking, indicating something is wrong. We have built-in logic mode to change colors. So the thresholds that we mentioned for the previous devices. Of course, adjustable LED brightness and compact installation in the same 22.5 millimeter bore hole. Some of the industry examples of the SMI2-M are fuel automation. In this one project, the SMI2-M was integrated into an existing Modbus system without changing the controller's logic. Thanks to SPI mode, it could simply listen in on the data and provide operators with real-time color-coded visualization directly on the panel. So whether you're starting the project from scratch and integrating SMI2-M device in your Modbus network as a slave, for example, or just adding a SMI2-M device in a SPI mode on your pre-existing Modbus network, you can showcase the values. So for the fourth demonstration and final demonstration, I will open SMI2-M in the Tool Pro software and go over some of the things that you can change there. Let's open the other camera. So the same box, SMI2-M, plug it into the computer. As you can see, I didn't put the power or 24 volts into the SMI2-M device now, because the SMI2-M4 configuration is powered via the USB cable. So this is practical for the programming. Let's go over to the Tool Pro. Okay, as in the ITP-15M, on the top left, we click Add Device. Here we select now communication port 5. For the protocols, we will select akYtec auto detection protocol and click Find. The detection protocol successfully found the SMI2-M device. I'll lower this or make it smaller so you can see the Add button device now. We click Add Device, and the SMI2-M is successfully added. Right-click Show Tree opens the whole tree, so we can go over the things we can change. First, we have RS485 interface. So here we can select baud rates, data bits, stop bits, so you can successfully connect the SMI2-M into the Modbus network. We have settings for master mode. So when the SMI2-M is set up in master mode, we can select protocols, targeted devices, etc. We have settings for spy mode. We get Modbus common settings, so address in slave mode, byte orders that we mentioned earlier, a save state timeout, and other things. And for the display, we can change data type, so time integer, real string, or even image. We can change color, of course, red, green, yellow. Here is the blinking that we mentioned. We can turn it on or off. Here we can see the values that the SMI2-M device is measuring. And here are the zones for the thresholds. So 5 zones, we can enable the zone. We have set the upper limit, even set the hysteresis for the values, change the color, red, green, yellow, and of course the blinking. On the top right of the Tool Pro interface, we have the parameter lists, which is beneficial for integrating into the Modbus network, because here we can quickly see all the addresses of specific parameters that we want to read. So these are all the Modbus addresses, as you can see. So we can even change color, blinking, etc. Okay. I'll stop sharing the Tool Pro and share the presentation again. Okay. We slowly came to the end of today's webinar, and I want to conclude what we have talked about today. So to summarize, our ITP11 is ideal for when you want a simple loop-powered monitoring with no extra power supply. The ITP17 is our universal indicators, so combining flexibility with color-coded alarms and control outputs. All types of signals can be read. The ITP15M provides intuitive bar graph visualization, great for processes where trends and levers are more important than specific numbers. And at the end, we talked about SMI2-M that integrates seamlessly into Modbus network, offering powerful visualization without touching the existing logic. Together, all of these devices offer a compact, robust, and versatile solutions for process monitoring across many industries. That will be all for today. Thank you for attending. I'll ask you or leave some time for any questions that you have. If you have any more questions, let's see. Okay, I see my colleagues we're answering some of your comments. Okay, I don't see any new questions. Anyway, if you have any questions, any more questions, you can contact, you can find the email and contact us on our website, akYtec.de. And I want to thank you all for joining us today. It was very nice meeting you. I'm happy that people from all around the world came and joined us today to showcase these indicators. So thanks again. And I hope we'll see each other again on some other webinar. Thank you very much. Bye.
Thank you. Bye.
Thank you very much. Bye-bye.
Thank you. Bye-bye. Take care.